Hi everyone, and welcome to my presentation. This is focused on alternative approaches to evaluating ecological outcomes from environmental stewardship initiatives, and asks the question, are they a reasonable proxy for expert collection of field data? This is a study that was conducted together with some colleagues, Ryan Plummer, Marilyn Jolino, and Gillian Dale. All of us are from Brock University in Ontario, Canada. And the study was also a part of a partnership between Brock's Environmental Sustainability Research Center and Niagara Parks, which owns and operates land adjacent to the Niagara River, including the iconic Niagara Falls, which you may have heard of, and I'll show you a map to show where that is, if not, in a bit. Okay, so I don't think that it will be controversial to say that monitoring and evaluation of environmental stewardship initiatives is important. It's important to understand if you're actually achieving the objectives set out and to allow you to make adjustments if not. And the main way, or the conventional way, in which this monitoring and evaluation occurs is through expert collected field data. But there are a number of reasons why monitoring and evaluation may not happen. And these include the cost. Often these sorts of initiatives are funded through short-term grants, and so ongoing monitoring is not an option. The time required to do them, and sometimes even lack of access, where you may not be able to get into the site. And so there's been a lot of work done to identify other methods to make these assessments, including remote sensing, the use of citizen scientists, and the use of stakeholders or site visitors that may provide a viable alternative or else a complementary approach to these kind of conventional expert collected field measurements. But when we think about using these as a tool for evaluation in practice, and certainly in research, there's no consensus on how well they perform. And as a social scientist, I'm particularly interested in this question because I often rely on people to tell me about ecological outcomes. And so I was very keen to undertake some sort of comparison to understand just what those differences are and how much of a difference there is between different approaches given very similar circumstances. And so this is a pilot study that examines and compares approaches to evaluating ecological outcomes from a single environmental stewardship initiative. So we used an approach that compared 4 different methods for this evaluation. They included an expert who collected field data. This was a consultant hired by Niagara Parks. Citizen scientist assessments, stakeholders or casual site visitors. I'll refer to them as stakeholders going forward just because that's the language in the slide, but it might be more helpful to think about them as just site visitors that may go to a site once or twice a year. And finally, remote sensing. So citizen scientists and the stakeholders were recruited from the local community from a range of places, birding, naturalist clubs, just students and anyone who was interested in participating. Each group participated in a single data collection day in July 2019. These days were about 2 days apart between the 2 groups for a single grassland restoration initiative. There were 2 sites, but I'm going to focus on one, the Lilac Garden site, which is on Niagara Parks property. So to show you where this site is, you can see the Niagara River running from Lake Erie to Lake Ontario. It also forms the border between the US and Canada. About halfway up or a little better, you can see Niagara Falls, Ontario, and Niagara Falls, New York. And just above that is a red star, and that is where the lilac site is. It's a tourist site that has a range of different lilac bushes, but it also has a portion of the property dedicated to native grassland restoration, and that's managed by Niagara Parks. So I'll briefly go through how data collection happened for the two groups of people that we engaged in the research. I won't speak so much to the remote sensing, but if you have questions later on in the live kind of panel Q&A session, I can speak more to that. So we had 20 citizen scientists and 16 stakeholders, a few less stakeholders just due to some attrition between when people committed to participating and the actual day. Each group started at 6 in the morning, which may have been part of the reason why we only had 16 in the one group. And there were some differences between how they were treated. Citizen scientists received training, they received a variety of resources, and they spent a fair amount of time at the actual site. So they were given a lot of kind of guidance and resources in order to be able to collect the data. Whereas stakeholders were very briefly familiarized with a couple of key bird species that we were interested in, but received no extra resources and spent less time in the field. So when we took them out, we gave them a questionnaire that had very similar questions between the two groups about assessing vegetation, assessing the different bird species that they observed or heard, and then we asked them also to take some time and assess overall site health at the end. When they were in the site, they spent some time at 3 different quadrats. Those were 1 meter squared areas taped off to assess those quadrats and the area around them. And the questions in the questionnaire were based on the same data that the consultant was collecting. So there was consistency across the 3 approaches. So a couple of pictures of our citizen scientists in the field, assessing a quadrat and doing the overall site assessments afterwards. So I'm going to start with those overall site assessments. So we asked them for 3 measures. One was overall bird population health. The second was overall vegetation health, and then a final assessment that was overall site health. And I apologize that the statistical significance bars have somehow shifted, but I can speak to that anyway. So what we see is that overall bird population health, there was no difference depending on how or who assessed it. In this case, there's no remote sensing data because that's not something that could be assessed by remote sensing. In terms of overall vegetation health, that's where we start to see differences. So there was a difference between the overall vegetation health assessment of stakeholders and remote sensing, and also the expert collected field data and remote sensing. So they were those 2 differences existed. And then when we look at overall site health, again, there was a difference between how stakeholders were assessing overall site health and how it was assessed using remote sensing, and then again between the expert-led field data collection and remote sensing. What's interesting to note here, probably for you, is that there was very little difference actually between the citizen scientists the stakeholders, and the expert-led field data collection. And we were also interested in how kind of the baseline level of expertise that these individuals brought in to the study may influence their ability to assess the site above and beyond the training or lack of training that we provided them. And so we did that, and there was no difference in the results when they were grouped by their level of expertise. Of course, we have a very small sample size, and it is a pilot study, but I think that's interesting nonetheless. So now we'll move on to kind of something a bit more fine-grained. So we asked some questions, site assessment questions about different metrics around vegetation. And all of these graphs that I'll show you are based on a mean rating out of 5. So 1, sorry, is very poor and 5 is very good. And that's the same for the previous slide and also the next one that I'll show you. So what we can see here is that there's a difference again between the citizen scientists and remote sensing and stakeholders and remote sensing for both vegetation diversity and vegetation density. I anticipate you're starting to see a pattern here that remote sensing tends to be much more optimistic about the assessments than any of the other approaches. And actually, all 3 other approaches tended to agree quite well, even at this kind of mid-range, about the state of the site. So if we move on to birds, this is where there started to be some differences among those 3 other groups. Remote sensing wasn't relevant here, but if we look at citizen scientists, stakeholders, and field data, we see some differences between citizen scientists and the expert collected field data in terms of bird diversity, and between stakeholders and expert-led field data collection for presence of invasive species. So there are some differences, and in some cases there doesn't seem to be a clear trend here in terms of who's most optimistic and who's pessimistic about the site. But there are certainly some differences between those who have less training and those who have and the expert who went out and collected data. So here's where we get into the kind of nitty-gritty of these site assessments. So we asked each of these groups, and we asked the consultant or our expert to identify as many different species of vegetation as they could in the field. And what we found was that the expert identified 16 species in this site. We assumed that these were correctly ID'd, but of course that is an assumption. Whereas the citizen scientist identified an average of almost 6 species, and somewhere between 2 to 9, and stakeholders identified an average of about 3 species correctly, and those ranged from 0 to 10. So there's quite a lot of variability within these groups, and they're not identifying the majority of the species that the expert did. So the other thing that we were interested in was what's really driving people's assessment at the overall site health level. And so we ran a correlation and found that overall vegetation condition was the best or the kind of mid-range assessment that they relied on the most. It was the most consistent with overall site health, but a few others also were correlated. Vegetation density, vegetation diversity, and bird diversity was kind of the lowest that was still statistically significant. There was no relationship between how individuals assessed invasive species, bird populations, soil exposure, and the number of plant species accurately ID'd. So to get to kind of the point here, can we actually use these approaches as a proxy for expert collected field data? And again, I'll mention that this is a pilot study and of course more work needs to be done, but based on what we found here, for broad assessments, I think the evidence is showing us that there is potential for citizen scientists and stakeholders to provide these sorts of assessments. But when we get down to especially the species level, but more fine-grained assessments, an expert may be required. And as you saw in the graphs, remote sensing results tended to be really optimistic compared to any other approach. And so, we urge caution and of course more studies required on that front. So I think I'll end there. I just wanted to maybe mention that, beyond just providing assessments, the citizen scientists and the stakeholders expressed kind of other benefits of participating, and I have a few quotes in that greenish box on the right side. And of course, those who study citizen science know all of this, but wanted to flag that, beyond just these kind of straight comparisons of how well they're assessing the site in relation to how an expert assesses a site, there are all these other less tangible things that go along with these other approaches that should be considered in the future. So thanks very much for your attention today. I look forward to connecting with you in the panel Q&A, and feel free to contact me by email or by Twitter if you have any questions in the meantime or afterwards. Thanks so much.